Let's take a look at two problems. The one on the left, we're going to focus in degrees, and then the one on the right, we're going to focus in radians. So if I give you these four angles, I want you to be able to identify which one doesn't belong. So your first instinct should probably be something along the lines of, well, let me see what they look like if I go ahead and I graph these angles. Now that you have a little bit of practice graphing these angles, this should be a little bit easier to be able to do. So for example, if I'm looking at 90 degrees, well, I know 90 degrees starts there and it's going to end here. If I want to make negative 270 degrees, well, that means I'm going down or backwards negative 270. So if I again start at my initial side, but now I'm going to go this way, and I'm going to end at the same angle here. Well, as it stands right now, these two angles look exactly the same. Let's keep going. If I take a look at negative 90 degrees, that means I only went down negative 90 here. All right, so now I'm adding in this new one. So right now, negative 90 is different from these top two. Let's take a look at 450. So 450 is way bigger than 360. If you think about it, if I go one full rotation, so I go all the way around 360 degrees, the question is how many degrees do I have left to get to 450, right? So I went 360, I got to get myself to 450. How many more degrees is that? Well, 360 to 400 is 40, plus another 50 is 90. So that means I'm going to end at this top angle again. So you should be saying to yourself, well, the 90 degrees, the negative 270, and the 450, they all look alike. And we're going to talk about what that actually means. What is the relationship when they all look the same? Negative 90, on the other hand, means that we went down 90 degrees and we are different from the rest. Let's keep that same idea, but take a look at radians now. So on this right side, I've got pi over 6 radians. So keeping in mind with your unit circle, pi over 6 is about 30 degrees. So that looks something like this. Okay, that's not necessarily 30, but I tried. All right, negative 11 pi over 6, that means we count backwards from, again, that initial sign. We count backwards 11 of them. So that means if we count backwards 11, we are going to wind up at the same exact position. So right now, these two angles are graphed exactly the same. Next, if I have negative pi over 6, that means I went down 1 pi over 6. So I'm looking at this angle here, which as it stands right now, that is not the same thing as my top two. And then if I have 13 pi over 6, well, let's think about it. We know for the pi over 6 family, we have 12 of them that make one full rotation. So if I have to get to 13, it means I went one rotation a little bit higher, so I'm currently at 11 pi, or sorry, at 1 pi over 6. So the one that does not belong is actually the negative pi over 6. That is the one that does not belong. Another way to think about that 13 pi over 6, if you want, is if you, again, go back to your family of circles, and you count 1, 2, 3, 4, 5, 6, 7, like so on and so forth. You just keep counting around the family of circles, the family of angles, and that will help you figure out what you're doing. So what does it mean when they look like they are exactly the same angle? Because again, they aren't the same angle, they just look like they're drawn exactly the same. So what that actually means is those are called coterminal angles. And where we get that name from is, well, co means to share and terminal means ending. So we say that a coterminal angle, they are different angles. So say for example again, 90 degrees and negative 270 degrees. They are different numbers, but they wind up actually looking the same. So if you take a look at this picture here, you'll notice that 45 degrees and negative 315 degrees, they share the same terminal side. So all angles have to start at that positive x-axis right here. But then this one, you'll notice that 45 rotates up, negative 315 degrees rotates down. Now here's the thing. You could rotate as many ways as you want. So I could just rotate once to get 45, but I could rotate again, and then I get my next angle after that. I could rotate a third time, a fourth time, so on and so forth. I could also rotate a negative time once, a negative time twice, and so on and so forth. As long as it ends at the same terminal side, we can say that those sets of angles are coterminal. So I'm going to give you an example of what that looks like. If we take a look at this picture here, 45 is our first angle that we're looking at. I rotated up once 45 degrees. Then I rotated down once at negative 315, and I end up at the same terminal side. Well, if I wanted to rotate up a second time, well, that means I'm at 405. So what I mean by that is I was at 45, but now I had to do a complete another rotation. And what's another rotation? 360 degrees to get to my next one, 405. If I wanted to rotate a third time, Well, then I have to go another full rotation, and that's going to get me 765 degrees, which, as you can see, that's starting to think about, what the heck, how many rotations is that? On the contrary, I could also rotate down as many times as I want. So if I rotated down once, I'm at negative 315. If I want to go another full rotation, that's going to get me to negative 675 degrees. So again, if you notice, all of these angles are located at the same exact spot, all wind up being in quadrant 1. Now, your coterminal angles don't have to be in quadrant 1. You can have all of your angles be in quadrant 2, or in quadrant 3, or quadrant 4. It does not matter the location as long as they all have the same angle. So again, what's this relationship? They basically differ by a full rotation. And when you think of that mathematically, how are we actually able to compute that into something that makes sense? So if we think about it, we are going to take our given angle, so again, whatever it is, in this case, say it's 45, and then you're either going to add another rotation, so add 360 degrees, or you're going to subtract a rotation, negative 360 degrees. And again, you can do this by as many times as you want, so that just means you can keep adding or you can keep subtracting. It is up to you depending on what you are searching for. Okay. So let's go ahead and try some examples here. If I want to find a positive and a negative angle that are both coterminal with 40 degrees, well, I'm going to start off with the positive one. So I start with my given angle, that's 40 degrees. And if I want another positive coterminal angle, well, I'm obviously going to have to add here. Why do I have to add? Because I need this number to be positive. So 40 degrees plus 360 degrees, that's going to get me 400 degrees. So that is one positive coterminal angle. If I want another positive one, I would just add 360 degrees again. Now for a negative, if I'm starting at 40 degrees, I'm now going to have to subtract because that's the only way that's going to get me a negative answer. So 40 minus 360, that's going to give me negative 320. Oops. Okay. Next, I want to find one with negative 538. So I start by writing negative 538 degrees down. Now I'm thinking to myself, I know a full circle is 360 degrees. So if I'm all the way at negative 538, I know that if I add just one rotation, I'm only going to become a negative number. See what I mean by that? Ready? Negative 538 degrees plus 360 degrees. That's going to only give me negative 178. So as it stands right now, this is another coterminal angle, but it's not positive, it's negative. So I can actually put that for my negative coterminal angle. All right, so that means if I don't have a positive number yet, I got to keep adding. So if I add one more time, then that's actually going to give me a positive number. That's going to give me 182 degrees. So that's just something you have to keep in mind about. When I ask you for a positive or a negative, make sure if it's a positive, it has to be an actual positive number. A negative coterminal angle would have to be negative. So when you want to find more coterminals, you just literally keep adding or you keep subtracting 360. Now you might be wondering, why did I choose to add in the first place? For a negative, for example, I could subtract, right? If I did negative 538 minus 360 degrees, I'm going to get another negative angle. That's totally fine. That's your possible answer here. You literally could subtract 360 for the rest of class if you wanted. I don't recommend that. But if you did, you would keep getting coterminal angles there. All right. Then I want you to try this one on your own now. So here's a starting angle, 52 degrees. And I want you to find two positive coterminal angles and then two negative coterminal angles. So basically all you got to do is you got to add 360 to be able to get positive ones. And then to get your negative ones, go ahead and subtract 360 for that first one. And then you're going to do the same thing for negative 315 degrees. So give this video a pause while you do it, and then you can unpause it to check your answers. Hopefully you have paused your video and now you're ready to check your answers. So here you go. Please make sure you have something similar to this. Again, these are not your only possible answers. If you wanted to add 360 50 times, that would work as well. I just did a 1 and a 2 rotation when I added it. So that is finding coterminal angles in degrees. Next up, we're going to look at taking coterminal angles in radians. Coterminal angles in radians. So it's just like with degrees, but obviously now instead of using degree symbols, we're using radians. And that also means a slightly different measurement. So for example here, you'll see my first rotation is pi over 3 radians. If I then rotate down, I can meet at the same terminal side if I go down negative 5 pi over 3. If I wanted to rotate a second time in the positive direction, I would be at 7 pi over 3 radians. If I wanted to rotate one more time in that positive direction, I'm actually going to be at 13 pi over 3 radians. And then lastly, if I wanted to rotate down just one more time, so after negative 5 pi over 3, that means I need to go one complete rotation more. Oh, yikes. Yep. All right. That would bring me to negative 11 pi over 3. Now, again, I chose angles that were all located in the first quadrant, but you could have coterminal angles located in any of your other quadrants. So let's go ahead and get the actual formula for coterminal angles in degrees. Boom. You take your given angle and then you add or subtract 2 pi radians. So again, say you kick off with that pi over 3. That means I'm going to add 2 pi to that, or I'm going to subtract 2 pi to that. So to give you that visual, just again, I start with pi over 3, and then I might want to add 2 pi. Now you might be looking at this and going, well, wait a second. I've got a fraction and I've got a whole number. How do I add fractions and whole numbers? Well, hopefully you're telling yourself, all right, I got to turn that second one into a fraction. And then you have to have a what when you add or subtract? You have to have a common denominator. So make sure you have a common denominator. Well, how the heck do I do that? Well, obviously between 3 and 1, I know that I want to make my bottom 3. But that being said, you can't just change the bottom, you also got to change the top. So that means I am multiplying this by 3. So that gives me 6, which should make sense because if you're adding 6 pi over 3, well, if you look on your family of angles, you know that there's 6 pi over 3 angles as part of the unit circle. So then all you got to do is we take our first number, so 1 pi over 3, plus our second number, 6 pi over 3, and that should give us 7 pi over 3. So if I go back to the previous slide, remember the number of 7 pi over 3, that should be my other angle. Ta-da! So that's by adding 6 pi over 3, or adding 2 pi. All right, let's go ahead and try some examples. So I have pi over 4 to kick things off, so I'm going to take pi over 4, and I'm going to add 2 pi. Again, why am I adding? Because I want to get a positive one. So if pi over 4 is already positive, it's pretty small, I need to figure out another rotation. So I put this over 1. And again, I need to have a common denominator. So if my left side is 4, that means my right side has to be 4, and then this top number is going to become an 8. So then technically this is 1. So 1 plus 8 is going to give me 9 pi over 4. And then obviously write radians after that. Now to get a negative coterminal angle, we're going to do the same thing, but instead of adding 8 pi over 4, we are now going to subtract 8 pi over 4. So once again, if you notice, I've been putting a coefficient in front to make it a little bit easier. So 1 minus 8 is going to give me negative 7 pi over 4 radians. And again, just like we did with degrees, you could keep adding or subtracting as many times as you want. These are not the only answers. You could add a second time, a third time, a fourth time, so on and so forth. All right, next we have 7 pi over 12. So again, I'm going to kick off by adding 2 pi. And if I add 2 pi, let's think about this. So my denominator on the left is 12. So let's make this one a 12. If I change the bottom, I got to change the top. So 2 times 12 is going to give me 24. Yep, that looks like 24. So now we add them together. 7 plus 24 gives me 31 pi over 12. And then again, we can go ahead and subtract. So I'm going to take 7 pi over 12, and then minus 24 pi over 12. And if I actually go and subtract those, that's going to give me negative 17 pi over 12 radians. Okay, so this top one, this is my negative coterminal, and then this one here, that's my positive coterminal. Again, remember, if you say it's a positive coterminal angle, your angle better be positive. So that being said, let's take a look at our next one. This time I'm starting with negative 26 pi over 11. So if I want to get a positive angle, I'm going to have to start adding, because the only way to get positive is to start adding here. So if I add 2 pi over 11, so that means, oh sorry, scratch that. I was speaking while writing at the same time. That didn't go so well. All right, 2 pi over 1. Sorry about that. That means we have to change the bottom to be 22, which means that the top, oh my gosh, wow. Okay, we're really not killing it right now. Let's just go from scratch. Here we go. Negative 26 pi over 11. I'm adding 2 pi over 1. Okay. The bottom we changed to 11. The top we changed to 22. There we go. So now I add them together, and that's going to get me negative 4 pi over 11. Now we've got a slight issue. We cannot stop and say this is our positive coterminal angle because this number ain't positive. But what we can say is our work's done for us for the negative. We can just go ahead and say, all right, you know what? We'll make that our negative coterminal. But to get our positive, we're just going to have to keep adding. So negative 4 pi over 11, we're going to add 22 pi over 11 again. And that's going to give us a positive 18 pi over 11, which, yay, that is now positive. So that means we are done. We've now found a negative coterminal and a positive coterminal. All right, go ahead, flip the page. Let's keep rolling. So what you're going to try is you're going to try adding 2 rotations for positives and then also 2 rotations for negatives. So to give you a little bit of assistance for this first problem, we say, okay, if I want to add pi over 3 to 2 pi, that means I'm really going to be adding pi over 3 plus 6 pi over 3. Hopefully you're confident as to why it's 6 pi over 3. Again, it was 2 pi, but we got to change it so it has a common denominator. So when I do add those together, hopefully you got 7 pi over 3 radians. Now if I want another positive coterminal angle, all I got to do is now take my 7 pi over 3 and add another 6 pi over 3. When I do that, I'm going to get 13 pi over 3. So hopefully you're okay with that as of right now. Now we're going to do the opposite. We're going to go ahead and subtract so then we can get negative coterminal angles. So if you want to try it, go ahead and do that now, pause it, and then keep playing when you're ready. So I can take pi over 3 and now subtract 6 pi over 3. So technically that's 1 pi over 3 minus 6 pi over 3, which means I should now get negative 5 pi over 3 radians. And then again, if I want to get one more negative, I'm going to take this number now and subtract 6 pi over 3. So now you should get negative 11 pi over 3 radians. All right, so if you stuck with me for this problem, let's see if you can now go to the next one. So your next angle is negative 5 pi over 6. Your goal is to try to get 2 positive coterminal angles and then 2 negative. So for positive, go ahead and start adding. For negative, go ahead and start subtracting. So pause it and then check it, see how you did. All right, so is this what you are getting for your answers? Again, these might not be your only scenarios. I just chose to add once and twice. If you wanted to sit here and add 3 times or 4 times, by all means, but I probably wouldn't suggest wasting your time doing so. All right, so those are all involving pi. Obviously, it's fun because that means you have to find common denominators, but I did tell you that it's not always going to have pi in your radians. You could have whole numbers for radians. You could also have decimals. Decimals are usually uncommon, like I said, but if you do have a whole number or a decimal, you have to think about this in a slightly different way. When we want to add 2 pi, for example, so say I take 2 radians. If I want to add 2 pi, we don't say, okay, this is 2 plus 2 pi radians as our answer. We want to be able to get this as an actual number. So that being said, I need to think about 2 pi as an actual number, so as a decimal. So that being said, we know that pi is equivalent to 3.14. Well, that means then 2 pi is equivalent to 6.28. So what I'm going to do here is I'm actually going to do 2 plus 6.28. And then hopefully you can do that in your head, but if not, calculators should be handy. 2 plus 6.28 is going to give me a total of 8.28 radians. So that's how we're going to try these problems. So if I want another positive coterminal angle, that means I'm going to add 6.28 again. And if I add 6.28, we're now looking at 14.56 radians, of course. Don't forget those units. So those are two positives. So I'm going to go ahead and clear this screen so that we have space to keep writing more. So we said this is, sorry, oops, wrong. This is 8.28 radians. I don't really have space, so I'm not going to write the unit right now. And then I've got 14.56. If I want a negative one, that means I'm going to take my original number, 2, and now I'm going to subtract 6.28. So my first negative coterminal angle is negative 4.28. And then if I subtract 6.28 again, that means my next coterminal angle is going to be negative 10.56. And again, all of these are radians. So again, you just keep adding or you just keep subtracting. Those are all coterminal angles. All right, so go ahead and give the 1.6 radians a shot, and then when you're ready, I will put the answers up here for you to check them. All right, here you go. That's what you should have gotten for your second column or your second row there by adding or subtracting 6.28. So those are coterminal angles in radians. Obviously degrees a little bit nicer, but radians, you still can do it. They just involve fractions. So now there's some practice in the white packet to be able to try.